We have theme number 8, presenting our LEP mini project, that is the GPS-Route-Analyser release 2. Our client as well as the instructor for the course is Dr. Padmanabhan Rajan. So if you haven't checked out our release 1, the link is in the description, so you can watch that previously. Now coming to release 2 features that have been added in the tool. So the very first feature is comparison of riders. So in the release 1 you can only provide data of rider 1, but now you can provide another rider with which you want to compare your performance. The second feature is to plot the map of the route of consideration. The very third feature is that the plots are now inside the application. So earlier a separate window or tab was opened for the graphs, but now the graphs are also plotted inside the application. The fourth feature is we have improved the user interface. And the very fifth feature is the logging feature that we have talked in our release 1. So let us look the tool into action now. Okay, so here is our interface. So you can see the status flag is ready. And the very first option is to select the directory of rider 1. So I'll just select, I have some files of GPX files. So I have selected those. So you can see the logs are generated on the terminal, which directory we are in, which file we are processing. So I have just kept 3 files. So here you can see the files are processed. Now it's time to select the rider 2's directory. Okay. Meanwhile, you can see that the rider 1's data has been given. Rider 2 is also completed now. So the rider 1 has these are the cumulative stats that the rider 1 has totally covered 11 kilometers distance. Rider 2 has covered 5.2 kilometers distance. This is what is the average speed of both, and these many number of rides they have done. So these are the graph plotting options. So very first graph is of distance versus date. So you can see that the rider 1 has 3 rides, and the following are the distances. Similarly, you can view the speed. So these are the 2 graphs. Now coming to the third point, functionality. So you have to add 3 points of the route containing the route of consideration. So let me just quickly paste it and come back. There you go. So this is the starting point latitude. This is the starting point longitude. This is the ending point latitude, longitude, and this is the midpoint. So the midpoint functionality, as we have explained in our previous release, is to distinguish between the ambiguity if the same 2 starting and ending points contain multiple paths. So you can write any latitude, longitude. I have just picked some random latitude, longitude from the morning ride files. So you can also write the cut-20 files over here. So let me just click on submit. I am asked whether I wish to start processing, and I have clicked OK. And let us wait for it to finish. Okay, so processing is over, and we are requested to switch to tab 2 for the results. So yeah, here I go. So you can see about the route stats. So the ride is actually of 2.3 kilometers. The elevated path in the ride is 0.3 kilometers. This is the highest elevation. This is the minimum elevation. This is the route map functionality, which I will come after a point of time. So these are the rider 1 stats. So the rider 1 is actually, you can see, rider 2 is performing better than rider 1, as his average speed is around a kilometer extra from rider 1. So here you can see the plots, that is of the speed versus date. So you can see like on which date what was the speed of the rider 1 and what was the speed of rider 2. Similarly, the time graph. So yeah, that's it. So now let us plot the map, and here you can see. So this is an HTML file. So you can actually zoom in, zoom out, and see what the path is. So this is what the complete route segment that we have considered looks like. Okay, so now coming back to the slides. So the one more thing that we have increased in this release is the performance enhancement. So we have talked about this with our client as well. So there is actually a trade-off between the accuracy of distance and the computation time. So what this trade-off really is, so there are consecutive frames, or you can say the entries in GPX files. So two entries are really close to each other. So while calculating distance, if the difference between the consecutive entries is taken to be 1, you can guess that the number of computations are more, and so is the computation time. But as we increase the difference between the entries, the computation time reduces significantly. So this is what this graph shows. Now the computation time reduces, but at the cost of inaccuracy. So this is what is the percentage error with each difference of frames associated with it. So you can see, like at 128 difference of frames, the percentage error is 4.52. So we have safely took the difference between frames as 64 for our application. As you can see that the computation time is almost 10 times lower than what was the previous computation time, and the percentage error is also very small. So this is another enhancement in our release 2. So thank you very much. LAP was really fun. Thank you so much.